Dear students, today we will talk about logistic regression. So, what is a logistic regression? Logistic regression is basically when your data is not quantifiable, or it is, you can say, it is more qualitative data, or in case if you have like some options like yes and no, or you have options like spam or not a spam, or say male or female, or you have options like like in surveys we have the option like strongly agree, agree, disagree. So when you have like words or like alphabets as an option instead of the numbers, then we use the logistic regression. So let's see that what is the mathematics behind the logistic regression and how people are using it. So it also comes under the supervised learning and the form of the learning here. So in this session, what we are like going to introduce, we have different types of logistic regression. The basic type is the binary logistic regression, in which we have the two options, either yes or no, or we can it can be studied for a situation between a binary outcome like dependent variable, or some explanatory variable which is called independent variable. So as I told you in the previous some of my lecture, that when we say that y equal to x plus b, okay, so it means that x is an independent variable and which is called explanatory variable. It explains what is going on in the independent variable, which is y. So we have this binary, or we call it as a dichotomous response as well, for the y defined as, and then we have a success as yes and failure as no. We want to model the probability, which is y equal to 1. So we have the two options for that one. And to have the to model the probability, we will see that how we can configure it. Can we divide into 50-50, or what is our threshold values? So with linear regressions, values may be outside the interval, right? So 0 and 1. And then for the probability of x, then we model it like b naught plus b1 x1, b2 x2, and the last value could be bk and xk. So here we require a link transformation that ensures our fitted values will vary between 0 and 1. And then we have a link function as well, which ensures that expected value probability should be between 0 and 1. And moreover, when you have linear prediction decreases, the probability goes close to the 0. Moreover, when the linear prediction increase, the probability goes close to the 1, right? So this is the main factor in it. Then, for example, you see the closeness, whether if it is going close to the 0, then we call it as prediction is decreasing. And when you want to increase the prediction, the values goes more towards the 1. Now here, in the G of this one, this is the equation, the basic equation, or we call as the link function. So link function is very much important here. So we have two options as like yes and no, and then the probability of getting a promotion. For example, if the person is getting a promotion or not. So the range is between 1 and 0, and like applying employing rating, what is the rate of the employing, whether he will get the promotion or no. And then instead of this one, if you have fixed point like 0 and 1, then it is very clear. But if you don't have a fixed points, like you have the values between 0 and 1, like 0.1, 0.2, 0.3, 0.4 till 0.9, or and then 1. So then your graph will look like the second one. Okay, so to understand the logistic regressions, we need to talk about the odds of the success. Like for example, in the probability, we know that if there is if there is some event happening, so we call as a p. If the event is not happening, we say 1 minus p, right? So this is how we express the odds of for the probability. And moreover, the values of the odds range from 0 to infinity, and the values of probability change from 0 to 1. Now let's take the equation for the straight line here. So B naught, which is the intercept, and it's a starting point for any regression line, and B1 is like the coefficient over there for the for the intercept. So here is the y-intercept, and sorry, and B1 is the slope of the line, as we discussed in the previous lecture as well. So slope is basically the tiltness and how much it is tilted toward the x-axis, right? So the slope will be lesser if it is more aligned with the x-axis, and the slope will be higher if it is aligned with the y-axis. So x is the value of the x coordinate, y is the value of the prediction basically. So here is the equation. This is a very basic equation: y equal to b naught plus b1x. So as we told that y is the dependent variable which depends on x, and b naught is the intercept of the line which intercepts with y-axis at point b naught, right? And b1 is the slope, or the value of slope, that how much it will be tilted, because it's b1, basically B1 has a power to tilt the X value. So more B1 and less B1 can impact the value of X. So this is most important thing to understand. Now we predict the odds of the success, what are the different odds? As I told you that the event could be happening and event could not be happening. So how we mathematically represent it? So we represent it like p of x and y minus p of x, and then we take a log of that one, okay? And then b naught plus b1x, okay? So exponentiating both sides, for example, if we take the exponential of the both side, so what will happen? So it will look like this one. So the log becomes ln over there, e power this one, and the values becomes with the inside the exponential. So sometime equation becomes more easier when when you put in exponentiation side. So both are equivalent one, and but both, sometimes it's easier for us to directly deal with the equation. Sometimes it's easier for us, especially in Python programming, so to we take the exponentiations as well. So in logistic regressions, what we have here, so this is this is the basic formula: y equal to b naught plus b1x. So this is what we got basically. So normally we get, like, for example, when we put the exponentiation, so it becomes more easier, it's more easier. So instead of writing all this, formulating, so we just write e power b naught plus b1x, and here, so this is how we represent it, right? And by this one, then y equal to this one, p of x, 1 minus p of x, and then we have y 1 minus p of x, and then, okay, so this way, we are playing with this equation, and we are opening the brackets and multiplying the y with the internal one, and then p of that one, and we are getting the value of y. So we got the value of the y, and then we also got the value of p of x, okay, and then and then we compute the value of y as well, okay. So we got this expression, okay. The equation of sigmoid function. So now basically sigmoids plays a very much important role in prediction. So this is the function of sigmoid, and we say p of x, and then e power this one, the same thing, we just extrapolate over here, and and you can see, if we cancel some of the effects, so here we have if we take it common, and then if we take this common, so the both side will be impacted, and we will get at the end, we will have this effect, right? So by this one, what exactly we get it, basically the power is minus, because we, from the numerator, we shift back to the denominator. Okay, so in this one, what we have it exactly. So in this one, we have very interesting, situation, and we define some threshold values between 0 and 1, and we said that if the threshold value is 0.5, if it is above that one, so it will be yes prediction. If it is below this one, it will be no prediction. So probability greater than 0 means the car will be breakdown, okay. And here the threshold value 0.5 indicates that the car is more likely to break down after 3.5 years of the usage, right? And the probability is less than 0.5 value round off to this one, the car will not break down, right? Okay, so this is how, like, we formulate or we think about different events. This is a simple code for us in Python, that how the logistic regression can be done. So I would like to highlight the main important code line which is helping us to find this one, which is to model it, right? So let me have the pen for that one. Yeah, so it works here. So here, fit logistic regression, this is okay. And this is the line you need to know about that one. Okay. Here is we have division, like you say, X training, X testing, okay, and Y training and Y testing. These are the different variables we have uh, inculcated for our program, and to supervised learning, and the data is the Titanic data. Okay. So since I reached Belfast yesterday, so there is a Titanic museum as well. So uh, yeah, so here the Titanic, data is here, and then we have yeah. So this is how to make the prediction. So the prediction is like logistic model. So this is the basically the function, the existing function. You can use this function. Okay, and then we have to evaluate it. So for evaluating the accuracy, so we have different score, like what is the accuracy score, it will find directly for you a precision score and recall score. These are very much important, right? And then it will print the whole summary, right? So this is how it looks. So here is these here, this is the summary, like we got the whole summary of that one. And then we have accuracy as well. We have precision and the recall, right? So these are the values which we got in this one. So let's go to the next section. Okay, yeah. Okay, so here is the results, like how it shows over here, which method you use, which date and time, all the summary results are here. So this is some imaginations about logistic regression, that how logistic regression is works in the binary form, a different one. So just to give an idea of that one, about it. So the selecting a right model is not enough for us, because sometimes we need a function that could measure the performance of machine learning model for a given data. Mm, like cost function quantifies the error between the predicted value and expected value. For example, if we expect some values and the real value, so we need to find the error between that one. And for that one, we need MSE, okay, or MSE means mean square error for the cost function given by. So this is the popular error finding method. So you can use that one. You can take it from your statistics books. Yeah, so here, the initial weight is there and the gradient is here, and global cost function. So by this way, this graph represent about the mean square error. Yeah, so this is more some elaboration with respect to log function and cos theta. So these functions are very much important. So the cost of the functions can be found out by this expression. So we already know that how 1 plus e power this one came, right, from the previous slide. We just need to fit into the cost function. Okay, so and this function is has already been minimized. Okay, so this is the initial one is the logistic regression model, and theta is this one, and we have the different values. So we have basic values are theta, we have the x, okay, and this values has been inculcated in the cost function. So this function is already existing in a Python, so you don't need to worry more about that one. Yes, if you want to learn about the mathematics behind it, so there it could be you can learn it more from from your mathematics teacher. Okay, so this is the end result we have for the cost function, and it has like minimize. So usually we go for minimize cost.